Good morning, everyone. Is it audible? My voice is audible?
Susmita, you are audible.
Yes, madam.
Okay. Please respond your paper ID 408
Yes.
413
Yes, madam.
415 415 416
Yes, ma'am.
417
Yes, ma'am.
421
Here, ma'am.
435 435 436
Present, ma'am.
Okay. Wait for the session chair to join. After that, we will start.
हाँ सुष्मिता मैडम yes.
Good morning, everyone. I, Susmita Patel, a research scholar at NIT Rourkela, welcome you to the first day of conference ICSPCRE 2024. I would like to invite the session chairpersons, Professor Susmita Kara Madam and Professor Prabhat Kumar Rai from NIT Rourkela for the virtual session of Track 4. Here is the brief biography of the session chairperson. Professor Susmita Kara received the MTech degree from Birla Institute Technology, Ranchi, and the PhD degree from School of Electrical Science, IIT Bhubaneswar, India. She is currently an assistant professor with the Department of Electrical Engineering, NIT Rourkela, India. Her research interests include microgrid protection, controller design, demand-side management, and application of signal processing and data mining in power system problems. She was the recipient of Power System POSOCO Award 2017 for PhD thesis. Second chairperson is Professor Prabhat Kumar Rai. He received the BS degree in electrical uh, engineering from IGIT Sarang, Odisha in 2000. The ME degree in electrical engineering from IIEST Sipur in 2003 and the PhD degree in electrical engineering from NIT Rourkela in 2011. He is currently a professor in Department of Electrical Engineering, NIT Rourkela. He was also a postdoctoral fellow at Nanyang Technological University, Singapore from January 2016 to June 2017. His research interests include the signal processing and subcomputing application to power system, power quality and grid integration of renewable energy systems. Total 8 papers will be presented for this track 4. The paper ID are 408, 413, 415, 416, 417, 421, 435 and 436. Please be prepared with your PPT. Maximum 10 minutes will be provided for each presentation and 5 minutes for question and answer session. So let's start with the paper ID 408.
Yes, ma'am.
You can share your PPT 408.
I'm audible, ma'am.
Audible.
First
You
of
can
all, good
start.
morning. First of all, good morning. I am Sandeep Bisla from School of Engineering and Technology from Manav Rachna International Institute of Research and Study. My study is this on rooftop power PV solar project, which is completed in this year only and covering the planning, designing, and execution with performance analysis for the power quality issues and with the mitigation suggestions in this paper. Covering in 7 topics, you can see the content. Firstly, an introduction, literature survey, execution installation work, methodology and novelty, research discussion, conclusion, and with future scopes and some references I will show you. Regarding the introduction, we know about that everyone is targeting the zero carbon emission by 2017. And also, we know renewable capacity now leading in high watt. In India itself, 430 gigawatts power generation is there, but renewable is 42%, and solar is only 17.28%. Now, because of the daytime only, solar is only contributing is 6.25% only. 6.25% only. Moreover, rooftop installations are 14.6%, 65% of total 17.28. Although current government are giving many schemes like PM Surya Ghar Yojana, and also MNRA gave the target of 50% by 2030, the renewable energy from 42 to 50, which is a tremendous increase of 30 times from 2014 to till date. That was 2.6 gigawatt, right now is 70 gigawatt. Although there are rooftop solutions are neglecting in many area, we can see the industrial is building. More of the building are empty, unoccupied, but we can use in a rooftop solutions. And height is a major issue in the rooftop because most of the equipment are installed in the rooftop. That can be solution by the raising the height of the installation. Even though we have to take care about the MPPT voltage because that is the main criteria to generate the voltage from the minimum to maximum if we selected according to that by designing the better string. If I'm talking about the literature survey, I'm going through many paper and I come to the conclusion why I'm going to this project. First is that sustainability goal, that's the SDG 7. You know about the affordable energy. This is also concerning about the publish on imposing PV solar installation industries. Delhi is the most polluted area and we have to have the solution of renewable energy. This is a sustainable and renewable energy. Daytime is a higher, although a nighttime is a higher, but industrial area, because of industrial area in NCR, daytime demand is higher. Again, a rooftop, which is ignored and underutilized spaces. We know about the PVC software and STAT software. So there is a big challenge and there is also useful software. I'll show both aspects in this area. Structure, if we mount on a rooftop, there is a big challenge that the wind speed we have to be bear on this structure. So we have to design like that only. Capacity calculation also challenge, well concerning about that and also covering in this paper. And power quality after installation, we getting the generation and we getting the saving, but there is a power quality issue which comes across. I'm showing in this paper. Please go through. Firstly, I go through the designing work. Can show you the flow diagram which I covered in this area. Firstly, I go to the plant load analysis with government regulation, then area identification and shadow analysis, layout preparation, and making SLT and cable routing and earthing ready. Going through the complete analysis of load calculation, that plant is 135 kilowatt connected load, and average monthly consumption was 22,362. We can see in the month on month consumption, and maximum demand was 55 kVA to the 115 kVA. Although Uttar Pradesh is giving a gross metering solution instead of net metering solution, and 80% of that could is connected load we can put solar. If I'm talking about the area, we have to go through the 4 5 aspects are there. If it is sand, we have to pre-structure. If it is cement, we have to give it the plinth. But waterproofing is a big challenge. We make whatever the solution, but waterproofing we have to done. PVC software is a useful software which will give you a irradiation percentage of that area according to longitudinal and altitude. Sun direction also you give which in which direction is suitable to install the cells, and shadow analysis is very fine in this area in software. We done a 3D diagram of that site and we make arrangement because there are multiple equipments over the roof like tanks like AC outlet, AC fan, AC condensation. So lots of things are there. We have to raise the height. we can see the picture is small, but there is I can explain you from the front side is 800 mm and the last side is 3.2 meter. So because there is a tanks and there are other equipments we have to cover. Also, we have to place the module to clean regularly. So module has to be placed like that only and to feasible for the maintenance in the regular mode. Making the SLD, we can see we make a solar array with the 16 module and that four strings are there. It will make 34.5 watt. DC fuse is there, then connected to the solar inverter and ACDB and then to main LT panel. Main LT panel is directly connected to the grid and the plant load. MPPT, I'm talking about that 500 to 700. I'm maintaining the MPPT within 500 to 700, although inverter has the capacity from 200 volt to the 1000 volt. But I'm maintaining it 500 to 700 for maximum output as I go through the catalog and I go through the many studies that best output is come from after 500 or 700, in between 500 and 700 MPPT voltage if I maintain it. These are the some makes and equipment which I use in this, like module as monocrystal, bifacial, Vari, inverter with iCloud software, Sangro, AC/DC cable, copper cables, polycab, ACDV 100 ampere, three phase, Recollect make. Structure is mild steel, hot dip galvanizing 80 micron, and earthing is chemical gel earthing, and LA is a early streamer emission type LA. Now about the methodology, I perform this whole study in the four steps. There is a complete 1 period analysis there. 1 period is complete analysis, 1 year range. One is before installation and another is after installation. Before installation, that is from April 22 to March 23. Installation was in April 23. So it's April 23 to April, March 24. That is after installation of solar plant. Four covering things, these area, consumption pattern of each, what is the contribution of solar plant contribution toward consumption, what was monthly saving or monthly contribution, power quality issue and mitigation, what was time across the power quality, how it tackle and mitigate that. And also we will see the what was the effect on MDI, maximum demand indicator, which is the biggest factor in the industries. Firstly, go through, we can see the consumption. When I put the solar and we can see the consumption. It's contributing from averagely 70% of the system. But there is no gross metering
Am
or
I
net metering
audible?
because, yeah,
Yes, 8 minutes is first. Okay, so within 1-2 minutes you finish.
yeah, this 100% consumption is there. So we are not putting the net metering. This is a monthly consumption. We can see that and month on month, depend upon the weather, its consumption is vary. If you're talking with the power factor, it was after installation. Before installation is fine, but after installation, whenever is not utilization of the plant, it goes to the dip down. But I mitigate by reactive power installation of the 15 kVAr and 3-step 5 giga, it goes to the 0.99. And maximum demand also decreases, which is 13.5% benefit are there. Now its maximum is 104. And I am also challenging the PVC software. As a PVC software, we can see PVC analysis show me this blue line, but actual generation was the red line, which is showing that it's minus 56 to 18%. I'm challenging that PVC software and which is shown with the proof. In PVC, we can say the yearly data is accurate if I'm talking about average, but in month on month, there is a big variations. Also, there is a shadow analysis of prediction of daily basis, daily wise, but depend upon that irradiation and all. But there is also a challenge, which is 4.5 hour to 1.6 hour. There is a variation in PV cyst. So we can depend upon this PI in conclusion. We can depend upon this software. We can take the help of this software, but still PVC software need to be amendment or need to be changed. And for the future, I can recommend these three. For the good quality, APFC has to be installed. Some research has to be go for the APFC installation work, because I've done a small area. It's a big hope or big, and PVC software needs greater precision. Also, most of the work are pending on this. And artificial intelligence is the best, like fuzzy logic and this. We can numerous permutation and combination can make and do a better result in future. Some of the references are here. Thank you.
So how the power quality is taken care here?
Power quality, I'm taking care by correcting the power factor, ma'am.
Correcting
This
the power
power
factor. So how you
Yeah.
are correcting that power factor?
Power factor, because that is deep down from 0.9 to 0.89.
How?
Then I
How?
put a APFC. Power factor is a three-phase power factor for 15 kVR complete load within 3 steps.
Reactive power support.
Yeah.
That means connecting what? Capacitor.
Capacitor. Yes, ma'am. Right.
Okay, next. Thank you.
Thank you, ma'am. Thank you. Thank you very much.
Paper ID 1413.
My screen is visible, madam.
Please complete your presentation within 10 minutes.
Yes, madam. Thank you.
Okay. Yes, your screen is visible.
Yes, madam. So my title, good morning to everyone. My title is Performance Analysis of Wicket Gate Operation in Hydro Turbine Setup using ANNPI Controller. And these are my co-authors, and myself is CJ Krishna, who is presenting this paper. So this is the flow of this presentation. First, we will see the introduction, literature survey, objectives, methodology, result and discussion, conclusion, and reference. Now, we will see the introduction. First thing is the wicket control or governor is very, very important in any hydroelectric power plant. That governor control we are mainly, it is already designed with the mechanical system. Now, in our paper, we are discussing if the governor is made up of digital, then what are the advantages, like how we can control the stability and efficiency, how can we improve? That is our main objective of this paper. This is the introduction. And next, literature review. I have gone through some of the papers which you can able to see here. So these are the literature review papers which I have gone through, and some more papers are there. Then main objective is here. We are developing an ANFIS PI controller, and we are comparing it with the already existing proportional integral PI controller. By using MATLAB Simulink, we are designing this one, and we are focusing mainly on stability here. Then first we will see the PI controller governor control action we will see. And here we are using this equation in order to develop or in order to design the PI controller. V of t is equals to Kp E of t plus Ki integral 0 to t E of t d tau, where V of t is the control signal to the actuator, where Kp is a proportional gain constant and Ki is the integral gain constant, and integral 0 t E of t dt represent the integral of the error over time, which helps in eliminating the steady state error. To apply this hydroelectric context, consider the turbine and generator dynamic system modeling by using this first order equation. T d omega by dt plus omega is equals to K V of t, where T is the time constant of the turbine and generator system, and K is constant that includes the turbine gain and characteristics of the connected mechanical and electrical system, where d omega by dt is the derivative of the turbine speed. Now, what we are doing, we are substituting that V of t equation in this equation. Therefore, what we will get, t omega by dt plus omega is equals to k into that V of t equation we are substituting here. So in this way, we have developed the PI controller. Then we will see ANFI's PI governor control. Here, the first step is to identify the dynamic model of the hydroelectric power plant. For the governor control, the model might typically include turbine, generator dynamics, and the response characteristics to the gate position changes. Therefore, let the linear model for turbine governor control be T into d omega by dt plus omega is equals to k into V of t itself, where t is time constant, k is system gain, omega turbine speed, and V of t gate position. To start with the fuzzy logic design system, the inputs to this system FIS would be the error E of t and the change in error delta E of t, and the output would be the incremental control gain action delta V of t, which is used to adjust the gate position. Now incorporate this PI control action where the output of fuzzy system is adjusted by the integral of the error. The PI controller formula will be V of t is equals to Kp E of t plus Ki integral 0 to t E of t into dt plus Vf of t, where Vf of t is the output from the fuzzy system, which modifies this PI controller response to enhance the performance under variable conditions. Therefore, the dynamic PI controller becomes V of t is equals to U into t minus 1 plus delta V of t plus Kp into E of t plus Ki integral Z of t into d tau. This is the final equation which is necessary to generate the gate signal for operation of the wicket gate in the hydroelectric power plant. Now, these are the PI design. The first tabular column represents the parameters which are used to design the PI controller, and second tabular column represents the ANFI's PI design. Next, we will see the results. See here, by using the PI controller, here we are mainly focusing on the position of the wicket gate and the vibration which are caused in the wicket gate. Now you can see here, by using the PI controller, the position is overshooting here over the 1, and after some 5 seconds and all, it is becoming stable, and it is becoming stable, and it continues to be stable. Then vibrations also, if you see, we have designed it for 0.1. Vibrations are overshooting here and they are stable at 0.1. This is the wicket gate response versus time and vibration versus time by using the PI controller. Then this is the ANFI's PI controller. There we can see the improvement. See here, first one we will see the position, wicket gate position versus response time. It is achieving the set point very quickly without having any overshoot. And in this second one, where vibration versus time, it is settling less than 0.02. But previous one, if you check it, if you check it, it is settling above 0.1, but in this you can see at 0.02 only the vibrations are becoming stationary, and we are because of this only we are getting better stability here. So the conclusion is, in this transition period over PI controller, ANFI's PI controller demonstrates a notable improvement in both achievement of the desired turbine position and the reduction of system vibrations. With PI controller, the turbine quickly reaches the target position with minimal overshoot and vibration levels stabilize shortly after a brief spike. The introduction of ANN to the PI controller further refines the system's response as evidenced by the turbine's precise maintenance of position and an even lower vibration level, underscoring the advantages of integrating artificial intelligence with the traditional control methods. Overall, the data indicates the application of ANN PI controller in turbine systems can lead to enhanced stability and operational efficiency, which are critical factors in the performance and longevity of such systems. So these are some of the references which I have attached. Thank you, madam.
Okay.
If any queries, please.
So, how many inputs are there to your neural network?
1 second, madam. I will just show you. Can I share, madam?
Yeah.
Madam, here total number of membership functions we have taken 7 and number of epochs we have taken 167, madam.
No. What are the inputs to your neural network? ANN, na?
Yes, madam.
ANN. What are the inputs? Change in error, single input.
Yes, madam. Yes, madam. Change in error, single input, madam.
And number of membership function equal. So a neural network, what how many layers are there? Which neural network you have used?
Adaptive Neuro-Fuzzy Inference System, madam.
So you have directly taken from MathWork.
Yes, madam.
Oh, okay. Okay, thank you.
Thank you, madam. Thank you very much.
Next.
Yes, madam.
Paper ID 415. Paper ID 415. Is there 415?
As I'm audible, ma'am?
You're audible. Please share your screen.
Yeah, shared, madam. It's visible.
Okay. It's visual. Make it full screen.
Just a minute, ma'am. Now it's visible, ma'am.
Yeah.
Yeah. So good afternoon, one and all. Good afternoon, ma'am. And myself is Prashant Kumar, research scholar from School of Tribali. So I'm doing under guidance of research also. And my paper is analyzing line-to-line faults in DC microgrid through discrete wavelet transform techniques. So this paper presents an innovative approach of detecting, analyzing line-to-line faults in electrical power system using DWT and MATLAB Simulink in this paper. Gone through that, and these are the contents. That is introduction, literature, objectives, methodology, results, discussions, and conclusion, future scope, and references. And comes to introduction part. The DC microgrid are the decentralized system utilizing DC links and distributed energy resources like solar PV and batteries. So this DC microgrid gather the significant attention to their sustainable role in the energy integrating the enable energy resources. So and for system for the better system reliability. So we need to focus on the advanced control strategies and power management algorithm for enhancement of operational efficiency of the grids. But a more distinct element in the grid is fault. So that fault we need to distinguish as soon as it is affected to the reliability and the operation and efficiency of the system. So for that, some significant that so Fourier transformation and special technique analyzing techniques we are gone through that. In that, very commonly adopted one is Fourier transformation. That is especially that Fourier fast transformation techniques for analyzing the voltage and current waveforms in DC microgrids. So whenever a fault occurs, so these analysis method tool, so analyzing the signal in faults occur and in the DC microgrid and descaling the voltage and current waveforms into their constant frequency components. This FFT method, but this FFT method having some drawback that so this FFT is which only offers the frequency information best, and because of this best suitable for stationary signals. So but compared to the DWD offers advantages over that FFT in time frequency analysis. So this is very suitable for the non-stationary signals, most likely occur in the grids. So, and this DWD offers a less sensitivity to the noise and improving the fault detection and accuracy in dynamic and noise environment in the microgrid. And in this paper, I'm demonstrating the effectiveness in detecting high frequency component associated with the faults. So we need to select the appropriate wavelet base and decomposition levels critical for optimal performance of the analysis. So future that integrating with this real-time monitoring system that closely enhance the adaptability and resilience the DC microgrid architecture. And these are the literature reviews. I just gone through that one, some literature reviews, and
Your
these are the
slide is
some.
not moving.
Madam,
Your
now
slide is not your slide is stuck at the first page. It's not moving.
first it's not moving now, madam.
Yes.
Now it is.
Yes.
Now it is moving, madam. Hello, I'm audible.
Yes, yes, audible, audible.
Yeah. Can I continue, ma'am? Yes. Now it is visible, ma'am.
Yes.
Yeah. Thank you, ma'am. And these are the some literature reviews. So I just gone through that during the presentation during the.
But it is in introduction slide.
Okay, madam. I just come back again. Now, madam, it is changing.
Yes, changing.
Okay, madam. I can I present like this only?
But you have to scroll your slide, no?
Yeah, but if I made it full screen, means the slide is won't changing.
Okay,
from your
okay,
part.
okay, okay.
If I can I present like this only, ma'am?
Yeah.
Yeah. And so these are the literature reviews I gone through during my study, and comes to an objective. An innovative approach using discrete wavelet transform, that is DWT, and MATLAB simulating for detecting, analyzing the line-to-line faults. So that is the main first objective of my work. And second one is highlight the potential benefits of using DWT for improving the fault detection times and enhancing the diagnostic capabilities. So based on these objectives, I've gone through the studies, and I come up with hello. I've gone through that this proposed approach. This is the block diagram of DC microgrid electrical distribution network. So this electrical distribution network incorporate with the medium voltage and low voltage components. So the network starts with the transformer that is a step down transformer, that is medium voltage to the low voltage, that is 11 kilovolts to the 400 volts, and and various and this in this low voltage side and various branches consider that is representing B1 to B8 that distribute the power to a different loads and converter, that is branches are taken, and in each branch consider the converter, that AC to DC and DC to AC converters, indicating the network ability to handle both alternating current and direct currents in the loads. And the various presence of that is BES, battery energy storage system, electric vehicles, and solar photovoltaic cells. So integrating indicates the integration of renewable energy resources and storage solutions for the sustainable energy approach. So considered here. And I consider two loads here, load 1 and load 2 here, and that represents the end points for power consumptions. So various integrating renewable resources for here done in the for improving the reliability and reduction of carbon footprints uh, in the present paper. And I just taken that one fault in this grid, and just gone through that signal into this MATLAB Simulink. So here I consider the voltage waveform. That voltage waveform here we are observing this voltage waveform. This voltage waveform is break into is gone through this high pass filter and low pass filter. This high pass filter is capable of having the signals of decomposition signals of approximation coefficients and detailed coefficients of DWT. So uh, there's a low pass filters offers the approximation coefficients, and high pass filters gives the detailed coefficients. And these filters again gone through that dividing the signal into again two subdivided into two parts, and again this signal gone through that high pass filter and low pass filters again subdivided. So this process entire process will magnifies the signal into part by part, and finally the occurring clearly occurring the fault at where that point that fault occur and magnitude of that point we can easily identify that after sampling of signals. So these are the simulation parameters. I gone through this in the shown in that table. So here the DWT level 4 levels of samplings I gone through here, and the taken of value type is SIM4, and this is the data I gone through that through in the Simulink process, and finally and gone through that result. So when it comes to the DWT analysis, the wavelet the result waveform shows that the voltage of at the 0.5 before 0.5 and after 0.5, so there is a spike is there that indicates that there is a fault occur in that grid. And we gone through that Simulink here in this process, and filtering that by 4 samples level. So here D1 is the first sampling method. Sampling represents the 800 samples, decomposition samples are taken. Observing here, just observing a small spike here, but we can't able to clearly observing the magnitude and where the fault actually the occur. And again, it is this D1 is again magnifying the D1, and it will filter to the 400 samples. So here just clearly we can observe that the magnitude of the fault is quite observing clearly. And again this process is further process to the D3 and D4, and finally we are through for 200 samples and 120 samples in that D4. So we can clearly observe the voltage magnitude that spikes we are observing, that where the actually the disturbance or fault occurs in the grid. Based on this magnitude we can identify that so the severity of the fault, where that actually the fault occurs, we can gone through this spike. And these are the current waveform spikes. And and the clear in the second waveforms shows that impulse and the switching transient analysis just done here. And so based on this result, just processing this result, we can clearly mention that in this particular sample, the D4, so where that fault is magnitude is high, that we can easily detect that fault. So using this DWT, and the time taken for this one is very less to identify this. So when it comes to the comparison of time response techniques and the DWT techniques, the response time is in time response is generally slower, but here in the DW technique is faster compared to this typical response. And come to the sensitivity, it is lesser sensitivity for small variation, but here the DW is has a higher sensitivity in both magnitude and frequency changes, and robust in noise consideration, more suitable to noise, but superior noise immunity due to multi-resolution analysis in the DW technique. And these are the comparison, that is the flexibility and limited flexibility, but the DWT has a high flexibility, and cost comparison a lower cost, but initial cost of the DWT is quite high because of the advanced technology requirements. But overall reliability is good, reliability in a stable condition, but excellent reliability in grid in the particular in the grids with variable loads conditions and renewable integration. So comes to the conclusion. So here the summary of the key finding from the comparative analysis of line to line current faults from using DWT, and emphasizes the DWT as a powerful tool for enhancing the fault characterization and early detection of faults in the DC microgrid. So this from result we can conclude that one, this DWT has a higher efficiency and gives the best time response signal in the DC microgrid. And future scope for this potential achievements in the DWT based methodologies for future enhancing the fault detection capabilities is required, and opportunity for integrating DWT with advanced control strategies or machine learning techniques we can do for. And these are the references. Hello, ma'am.
Okay. Am I audible?
Excuse me, ma'am. Sorry, I'm not feeling well, madam. Actually, yes, tell me, ma'am.
Why
Yes.
DWT? Why not
Yes, madam.
other? Why not other signal
The response.
processing rather than DWT? Why DWT?
Yes,
What
ma'am.
is the advantage of DWT? As far
The
as my knowledge, S transform is more better than DWT.
Yes,
Then
ma'am.
why you have chosen DWT? Okay.
Yeah.
First question.
Yes, yes,
Then
ma'am.
come to your result slide. 10 and
Yes.
11 perhaps. Yes.
Yes, ma'am. Here in this. Okay.
Slide numberings are okay. So this voltage amplitude something written, na? So these are the coefficient. Which coefficient? Detail or approximation coefficient? Which coefficient you have taken?
This is the detail coefficients.
Yes.
Just.
Not audible. Which
Yes, ma'am.
coefficient?
It's I think approximation coefficients, ma'am. That is
Approximation.
Sure is often just a minute, ma'am. Just you. So often the detail. Sorry, excuse me. Detail coefficients, ma'am.
One more question.
Yes,
How many cycle? Sorry, how many samples you have considered per cycle?
sample, ma'am.
Huh? Yes.
Sample, ma'am.
Sample per cycle data discrete na DWT. So you must have considered some particular number of window size, that number of sample per cycle.
Yeah, ma'am. Here number.
Yes.
Yes, ma'am. Actually, I'm suffering from dengue, ma'am. And from past 15 days, I'm bedridden, ma'am.
You have simulated that that model?
Yes, ma'am. Yes, ma'am. But
Yes.
I didn't go through that properly because of my illness. Yes.
Okay. Thank you. Next. 416.
Paper ID 416.
Yes, ma'am.